All right, if you're watching the video, I would like you to please pause the video and do the basic x squared graph on example 1 and exercise 2, or exercise 1 and 2, whatever they're called. All right, section 3.2 is going to focus us exclusively on the x squared graph, which is called a quadratic function. Okay, I haven't used that term much, but just so that you know, quadratic refers to something raised to the power 2. So on both of my Cartesian planes, I've got my basic graph. I've just done it in pencil, so it's nice and light. Both of these exercises you should already know how to do. Okay, this is just what was on the test. So what I would like you to do is write down, I don't want you to do the graphs yet, for both exercise 1 and exercise 2, I'm going to give you 30 seconds. Write down what transformations are being done in both graphs. So for exercise 1, 2 things are happening. What's one of the things that's happening? Okay, I heard both of them. I heard somebody say right 4, and then I heard somebody else say down 3. Great job. That's both things that are happening. That's strictly a translation. Exercise 2, in addition to 2 translations, there's something else happening. So somebody tell me something going on here. We multiply the y's by -1. That's great. What else is happening? Left 2, and then up 7. Remember, you do the multiplying first. So you might do another like transition graph of the multiplying the y's by negative before you go left 2, up 7. Okay, I'm going to give you a couple minutes to go ahead and do those transformations. All right, exercise 1, I'm going right 4, down 3. So I'm taking each of these points, 1, 2, 3, 4. Let me count right, 1, 2, 3, 4, and then down 3, and then 1, 2, 3, 4, and then 1, 2, 3, and then 1, 2, 3, 4, 1, 2, 3, and then the vertex 1, 2, 3, 4, 1, 2, 3, and then the same thing on the other side when I go down 4 and or when I go right 4 and down 3. So there it is. There's my graph. It's been translated. It's the exact same shape as the previous graph. It has just been moved, put my arrows on the end, and there we go. That's that one. Okay. The next graph. I told you I would suggest doing a transition graph of the multiplying, which in this case, we're multiplying the y values by -1. So these end values are both +9. So when I multiply +9 by -1, they become -9 each. The next ones right here in the middle, these are both +4. So when I multiply those y values by -1, they become -4 each. So I'm going to put -4. I've got these little values that are y1. So when I multiply by -1, they become -1. And finally, the middle here, 0 times -1 is 0. I'm just going to make this dotted because this is not the final answer. This is just my transition because I don't want to do too many things at once and confuse myself. Now I'm going to take those dots that we just reflected by multiplying by -1, and I'm going to move them left 2, up 7. So left 2, 1, 2, and then up 7 makes the vertex go to here. Left 2, 1, 2, up to 7 here. This one, left 2, 1, 2, up 7. And I'm having a great time going left 2 and then up 7 to here. There we go. I can see it. Left 2 and then up 7 to here. And finally, left 2, up 7, and then left 2, up 7. So I'm just counting around. So you see that transition graph looks the same now. I'm just now making it nice and bright blue. And there we go. There's my graph. Those two problems are review. Okay, they should be. We are now going to build on that in our talk of quadratic functions. So my goal for the next, we got about 10 minutes before I need to give back the tests. I'd like to do these two problems. I'm going to do one, you're going to do one. So unfortunately, what happens, or what we're going to see, is not all quadratic functions. In fact, most of them are not written in this format right here. I call this right here vertex form. I'll tell you later what the vertex is. We'll define that a little more clearly in just a minute. But that's called vertex form. So what we're going to do here is I'm going to define a quadratic function. A quadratic function is this. We're going to use the letter p. P of x equals ax squared plus bx plus c. That's called the standard form. It's the standard form of a quadratic function. A, B, and C can be any number. And there's only one limitation, and that one limitation is that A is not equal to 0. We've got to have a squared term. So ax squared plus bx plus c, that is called the standard form of a quadratic function. That's how you will normally see a quadratic function written. A, B, and C can be any real number. And the only limitation is that A can't be 0 because we need to have a squared term. So notice in example 1, I've got my quadratic function and I've asked us to find the vertex and graph it. Okay, now I'm a little lost because it's not in the format that I'm used to seeing it when we learned about transformations here and here. So what we need to do, and this is the learning that we're going to do, is we need to transfer this into vertex form so that I can just read the vertex, meaning what's the translation on this problem. So here's how you do it. There's two steps we're going to go through in order to learn how to do this, and I will outline the steps in greater detail next time. But the first couple of problems, notice there's no number in front of the squared. This is the simpler type of problem. Simple doesn't mean easy. So here's what we're going to do. Again, I should have left a little room. Sorry about that. So grab a piece of paper. Step 1. Step 1 is I'm going to group the terms with x's. Oops, group the terms with x's. So I'm going to do this for my example, and then I'm going to have you do it for your exercise. So we're doing both of these things at the same time. So I'm going to group the terms with the x's. So all that means is over here in my function, I'm going to put the x squared plus 6x in parentheses. I'm going to leave a little space, and I'm putting the 5 outside. X squared plus 6x. I've not changed anything. I've just grouped the things with x's, the x squared plus 6x. Leave a little gap for yourself there, and then I've put the 5 outside. So please do the same thing for exercise 3. The one that you're doing. Group the x's and leave that other number outside. Okay, when I group the x's on this one, I've got the x squared minus 8x. I'm going to leave a little space and then plus 10. Okay, so all you've done is rearranged the terms. Now going back to my list, that's the first step no matter what. I'm going to write a step 2. We're going to leave that blank. Step 2 applies to what happens if there's a number in front of the x squared. That's the little bit more difficult situation. We'll come back to that next week on Monday. Step 3, we are going to do what's called complete the square. What complete the square means to do is you take half the number in front of the x and then you square the result. Yeah. No, we're not factoring here. When we have a number in front of the x squared, we'll have to do that. That's what blank step 2 is. We'll talk about that on Monday. Okay, so you're just a little ahead of the game. Okay, so this number is 6. What's half of 6? 3. What's 3 squared? So half of 6 is 3, and 3 squared is 9. Do the same thing on your problem. Write down what number you're going to add in the parentheses when you complete the square. What's half of 8? 4. What's 4 squared? Okay, it's always plus because we're squaring. So you might say, hey, is it minus because of the minus 8? No, it's always plus because of the 16. The last step in completing the square, or the last step in doing this, is balance the function. What I mean by that is in my function, I've now added a 9 inside the parentheses. I've changed the function. It's now different. So I have to balance it out. So in order to balance something, if I add 9, what do I have to do to get it back to where it was? Subtract 9. So outside the parentheses where this number we left out was, I'm going to subtract 9. That's my balance step. Do the same thing on your problem, please. What is the balance? So I added 16 in the parentheses. What am I going to do out here to balance my function? Okay, minus 16. Great. So here's the last thing, and then I'll start passing out your tests. So yes, you mentioned factoring. You were just a step ahead of me. X squared plus 6x plus 9. The reason we've completed the square is I've created something that I can factor easily. X squared is x and x. What are the two factors of 9 that are going to add up to 6? Okay, plus 3 and plus 3. Same thing. It should always be the same thing times itself. So what I've done is I've created a function x plus 3 squared, and then 5 minus 9 is negative 4. So we've put this in vertex form. So what I would like you to do is two things. The first thing is you're going to do that same thing. You're going to write it in Vertex form now on your example. And then as part of your homework, we're not going to do this now. We'll do this first thing on Monday. I want you to graph both of these. Okay, because the graphing is the review part. So you're going to graph both of these. So in my parentheses, x squared minus 8x plus 16. The x squared is x and x. What two factors of 16 are going to add up to -8? -4 and -4. Always the same thing times itself. That's what it means to complete the square. And so I've got x minus 4 squared, and then 10 minus 16 is -6. So what you're going to do now is you're going to graph both of those. And when we come back, I will also have another example for us to review that process. And we're going to then take the next step.